Hello friends, today we discuss sequence of real numbers. Okay, sequence of real numbers. Okay, sequence of real numbers. Okay, or real sequence real real sequence. Okay, sequence of real numbers or real sequence. This is the first class on sequence. Okay, this is the first class on sequence. First, we discuss sequence on a set, sequence on any set. Okay, then we discuss sequence on R. Okay, it is sequence of real number. Then we discuss some examples, some examples of real sequence. Okay, this is our discussion. Okay, so first we recall some notation of some special sets. Okay, n, this denote the set of all natural numbers. The set of all natural numbers, which are 1, 2, 3, 4, 5, and so on. Okay, the set of all natural numbers. Z, this is script n, this is script z. Okay, the set of all integers. Okay, one, two, three, four, and so on. 0, -1, -2, -3, and so on. Okay, so these are called positive integers. 1 to infinity. These are called positive integers. These are called negative integers. Okay, clear? These are called positive integers. Okay, and these are called not 0, -1, -2, -3. These are called negative integers. Okay, then rationals, the set of all rational numbers. The set of all rationals, rational numbers. Okay, the set of all rational numbers. Okay, such number P of the form P by Q, where P and Q belongs to Z and Q not equal to 0. Okay, P and Q belongs to Z and Q not equal to 0. The set of, this is a script Q, this is denote the set of all rational numbers. Okay, R, the set of all real numbers. Okay, the set of all real numbers. Okay, which are the real numbers? A set of all natural numbers, set of all integers, set of all rationals, and set of all irrationals. Combine these four sets, we get the real numbers. Okay, irrational means set of all irrationals. There are no specific notation, just write R minus Q. Okay, this is the difference. Okay, of two sets, just R minus Q. Okay, Q, set of all rational numbers, such as, for example, root 2, this is a irrational number, root 3, this is an irrational number, pi, this is an irrational number, okay, and so on. Okay, these are irrational numbers. Okay, so these and the set of all rational numbers, and we know the inequality n is containing, Z is containing, Q is containing R. Okay, and R equal to Q union R minus Q. Okay, that is the set of all rationals union the set of all irrationals. Okay, so to discuss sequences on R. Okay, our discussion is sequence of real numbers, sequence on R. Okay, sequence on R. Okay, that is real sequence, that is real sequence. Okay, yeah, so these are some notations of some special sets. Yeah, now first definition. Okay, now first definition is sequence on a set A not equal to 5. Okay, sequence on any set. What is the difference of a sequence on any set? Okay, sequence on a set A is just a mapping from N to A. Okay, any mapping F from N to A, any mapping F from N to A is a sequence on A. Okay, any mapping N from N to A is a sequence on A. So if F is a mapping from N to A, if F is a mapping from N to A, this is N, this is A, this is mapping F, so corresponding to 1, F1 corresponding to 2, F2 in general corresponding to N, Fn, and so on and so on. Okay, so F is a mapping from N to A, so F is a sequence on A. Okay, any mapping F from N to A is a sequence on A, and the sequence F is denoted by this, that is the image set under F. Okay, in order. Okay, this is the first element of the sequence, this is the second element of the sequence, this is the third element of the sequence. Okay, and so on. Okay, so any sequence on a set A is denoted as this. Okay, here now we discuss sequence on R. Now next definition, sequence on R. Now we discuss sequence on R. If we choose A, the set A as the set of real numbers. Okay, if we choose the set A here, if this set taken as real numbers, then the sequence is a real sequence. So sequence on R means any mapping F from N to R is said to be a sequence on R. Okay, sequence on R or real sequence. Sequence on R or real sequence. Okay, sequence on R or real sequence. That is, this is our n and this is our R. Okay. So we take a for example, let f from n to R such that f of n equal to 1 by n in natural number. Okay. So for 1, this is the mapping f. So for 1 there are 1 by 1, that is 1. For n equal to 2, this is n equal to 1. For n equal to 2, this is f of 1 equal to 1. This is f of 2 equal to half, and the f of n equal to 1 by n. Okay, and so on. Okay. So the sequence is f of 1, f of 2, and so on. That is 1 half, 1 by 3, 1 by n, and so on. This is a sequence on. Okay, this is the example of a sequence on R. Okay, so sequence is just a mapping on from n to R. Okay, a sequence on R is just a mapping from n to R. For example, this. Okay, this sequence is also denoted by this. Okay, or this. Okay, this is also denoted by this. That is fn equal to 1 by n, so we replace fn by 1 by n. This is the sequence. Similarly, fn from n to R such that f of n equal to n in natural number. Okay, this is also a sequence, and this is a sequence such that f of 1, f of 2, and so on. So this is 1, 2, 3, n. This is a sequence. That is, this is denoted as n. Okay. Here, this is a sequence. So we replace fn by n. We replace fn by n. Okay. Clear? Okay. Also, another example. Another example is f of n equal to n by n plus 1. N belongs to n. Okay. So this sequence is f of n equal to f of 1, f of 2, f of 3, f of n, so on. Okay. So f of 1, that is 1 by 1 plus 1 half, 2 by 3, 3 by 4, n by plus 1. Okay, this is a real sequence. This is also an example of a real sequence. Okay, this is also an example of a real sequence. Clear? So these are the examples of some real sequence. This also written as n by n plus 1, n by n plus 1. Okay. Clear? A sequence is also denoted as, the sequence is also, if fn is a sequence on R, is also denoted as first, within first bracket. Okay, or xn or xn or un or when, etc. Okay. Clear? These are also notation. These are also notation of a sequence in R. Okay. We generally these two use xn and when. Okay. Throughout the chapter, we generally denote a sequence by this. Okay. Okay. Throughout this chapter, a sequence is denoted by this or this, not this. Okay. This is also notation, but we use this or this throughout this chapter. Okay. Another example of a sequence are xn equal to sin n pi. Okay. N belongs to natural number. So this is a real sequence which is defined as x1, x2, x3, xn. Okay. Which are the elements? First element of the sequence is sin pi, then sin 2 pi, then sin 3 pi, and together sin n pi. Okay, and so on. Okay, this is a sequence. This is a real sequence. This is a real sequence. Okay. Similarly, e to the power n. This is also real sequence. Okay, e to the power n. Okay, minus 1 whole to the power n. This is a real sequence. Okay, sin n pi by 2. This is a real sequence, and so on. Okay, so these are the real sequence. Okay, that's it.